So now we want to consider cases where the leading coefficient of the quadratic isn't necessarily 1. So first thing we want to do is, if we have something like 2x squared plus 14x plus 24, okay? So here the leading coefficient is not 1, right? The leading coefficient is 2. So it's going to complicate our old technique a little bit. But we should always try to look at, is there something that we can pull out of everything? Is there a greatest common factor between all three terms? We sometimes will tend to just like kind of zoom in on what method we're doing right now and not consider the previous stuff, right, which was the greatest common factor. Here we can see that everything has a 2 in it. So we could actually pull that 2 out of everything first. Okay. And then it simplifies it to the case that we were talking about where a is equal to 1. So we just keep that 2 on the end here and we factor out that middle. In this case, that's going to be plus 3 and plus 4, right? Because that will multiply to 12 and add to 7. Okay. So here we have 2 times x plus 3 times x plus 4. So we have them all in a row here. And by the way, this also works like sometimes we might see something like x to the 4th plus 7x cubed plus 12x squared. And we might think, okay, well, that's not a quadratic. So maybe we can't factor that. But you could pull an x squared out of everything first and get x squared plus 7x plus 12. And now it is a quadratic, right? Now it's x squared times x plus 3 times x plus 4. So always look for that greatest common factor before you do anything. Now, of course, that's not always going to, work out. There's not always going to be a greatest common factor. So let's now look at a case where there isn't. 5x squared plus 7x minus 6. Okay, now we just have to face this one head on. We got to think, okay, how do we handle this problem? So let's go back to how we did it when a was equal to 1, when the leading coefficient was 1. We would say, okay, this is x, and we'd look for our combinations. We still want to kind of keep the same approach, but there's a few key changes. One, x times x is not 5x squared, but 5x times x is. And because 5 is a prime number, right, it's not divisible, it doesn't have any other factors, it has to be 5x and x. So we know that at least, right? And we know that this has to be 5x and x. Sometimes there will be multiple combinations for that first term, but for this one, this is the only combination we need to consider. So now we're just kind of considering all the combinations that would multiply together to give us that first term, the 5x squared. And now if we think about our a and our b like we did before, we still need a times b to be negative 6, right? If we think about FOIL, we still would just multiply a times b to get to the negative 6. The 5 has nothing to do with that, but it is going to change the middle term, right? Namely, when we do the outer and the inner, we're going to get 5bx plus ax. So this is going to be a plus 5bx. So here a plus 5b must be 7. So this changes things a bit. But it doesn't really change our strategy. We still want to just look for the terms that multiply to give us negative 6, the factors of negative 6. So do that here. We get negative 2 and 3, 2 and negative 3, 6 and negative 1, negative 6 and 1. Okay. And we want to think, okay, what if we multiply one of these by 5 and add it to the other one, will it give us that 7? And there's no, like, we also have to consider which one is which, right? Like, we have to consider -2 and 3, but we also have to consider 3 and -2, because we can multiply either one by 5. So we have to think about that as well. So these get kind of just faster with practice. Like, you just kind of want to try different combinations, but eventually you kind of like just go towards the correct one just with enough practice. But let's just kind of look at a bunch of these first. So if we do 5 times -2 plus 3, we're going to get -7, very close. So maybe we do 5 times 2 minus 3. So I'm looking at the second one here, and that's going to give us 7. So we get the answer that we need. So we're just looking at different combinations of like which one do we multiply 5 by, and then add the other number to get to that 7. So this tells us we multiply the 5 by 2, so that means it needs to go here. It needs to go opposite of the 5, so that when we do the outer terms, we would multiply those together. Okay. The 5 does not get multiplied by the term it's being added to, so it needs to be opposite of it. And then the a then will be -3. So maybe we make it a -3. So we get 5x minus 3 times x plus 2. So generally the strategy is the same. You're just going to have more things to check. Okay. So let's do another one. So let's do 6x squared plus x minus 1. Okay. So here, there's different things that we could have for these x terms, right? Because 6, that could be 6 times 1, or it could be 3 times 2. So we have to consider both of those. Okay, so we have to consider 6x times x. And so maybe I won't write the equals yet because we don't know which is which. We also have to consider 3x times 2x. So these are pretty different. Luckily, the other numbers aren't so large, right? We just have -1, which only 1 times -1 will give us that. So we don't have a lot of factors to consider. So you can even just leave it like this and kind of like write in the factors, maybe in a different color, just, you know, to kind of see, and then just kind of try it out. So like say, okay, would this one give me the right answer? So I have 6x times 1 is 6, minus 1 would be 5x. No, that's not going to work. Maybe try it the other way around. -6x plus x is -5x. No, that's not going to work. Maybe we do this, -1 plus 1. So 3x times 1 is 3, minus 2x is 1. So this one does work, right? When you do the outer terms, you get 3x times 1, which is 3x. When you do the inner terms, you get -1 times 2x, which is minus 2x. 3x minus 2x is 1x. Okay, so this is the correct combination. 3x minus 1 times 2x plus 1.